Hello everybody and welcome to this video in which we are going to be looking at how we can use Python code, specifically Python code from the matplotlib library, in order to create scatter graphs which we can then use to help us in our projects and to understand the data better. So first of all, we are going to import matplotlib.pyplot. We want pyplot from it as PLT, which is fairly standard. And remember, we need to make sure that we've actually got matplotlib, the library, installed on our system. We're assuming that we do. And then we can start to create some dummy data, so to speak. I'm just wondering why that's got an error as I'm speaking. It's because I misspelled pyplot, right? Obviously. So that's the nice thing about VS Code. It will show you the errors, right? That yellow error is saying, don't quite get what you're doing there. And of course, when I looked at it, I realised why not. It's because I missed the P. But coming back to this, we need some dummy data as well. Now, in our examples here, we're going to look at some really clear, what we call correlations in the data. So correlations come to links, I suppose, connections and links between things in data, and that it will just make a lot more sense when we get to it. So let's just get to it, right? So let's go for hours underscore revised. And that's we're going to give a list to this. So this is our variable. Remember, this is our variable. We're going to call it hours revised. Then we're going to have a list, and this is, well, funnily enough, the number of hours children have revised, right? So 1 hour. So when I say revised, imagine a test is coming. Some really important test is coming up. Maybe it's a computer science GCSE or A level or something like that. Whatever. It's a test. And the child has revised for 1 hour. So they've looked at their work for 1 hour, they've gone back over their notes, they've done some more coding for 1 hour. Okay, and then there's somebody who's done 2 hours and then 3 hours for more and more revision, you see. So more and more revision like that. So hours revised, and then we're going to say, okay, how does that connect? How does that link? How does that correlate to the actual percentage of questions correct? So remember, 100% would mean everything. So let's say somebody scores 100% on their exam. That means they are very smart and they get every single question correct. If they get 0%, well, they're not so smart, and they've got nothing correct, not even one question, not a sausage, nothing correct, right? And 50%, they got half right, half wrong. Obviously, in a very important test, we are shooting to get 100% right, or as close to 100% as possible. We certainly don't want to be getting 0% right. Okay, so let's have a look. Test scores, we'll do like that. So here's another variable. We're going to create a list, and we can put in, so imagine this is real world data, right? This is real world data. So the child who studied for 1 hour on their test, they got maybe 35% correct, not good. Child who studied for 2 hours, maybe they did a bit better, 42, still not great, I'll be honest. Child who studied for 3 hours, revised for 3 hours, maybe they got 53, not wonderful. The one who did 4 hours, starting to get a little bit better here, 62% correct, and then we get to, what was it, 5 hours, okay, they're getting a little bit more healthy. And then somebody who studied 6 hours, revised for 6 hours, maybe has got 81, and the child who revised for 7 maybe got 95% correct, really did a great job, right? Now you can already see, because you're smart, you can already see that there is a positive correlation, right? What does this mean? It means as one goes up, the other one goes up. Or as one goes down, the other one goes down, right? But let's keep it simple. As one goes up, the other one goes up. So the more hours you revise, the more you are getting correct. And that's the correlation. Now, one quick note, and we go over this in a deeper dive card about it, that doesn't mean causation, doesn't mean it necessarily. In this case, yes, right? In this case, yes, it is. The cause of doing well in the test is the fact that you studied more, you worked harder, and that is the causation. But we'll look at an example maybe later, or in a deep dive card, where it doesn't actually necessarily mean it caused it, right? And we'll talk about that more later. But let's focus on what we're doing, creating a scatter graph to see positive correlation. So how do we do it? We're using matplotlib, and it's fairly straightforward. Remember, we've imported the code here as PLT, so plot PLT. So what we're going to do is say, okay, PLT dot, and we want scatter. We've used bar before in a different video, or you may have used bar before. We're going to do scatter. And we're going to do hours revised, and that's going to be our x axis, our x data. So that's going to be going left to right, hours revised, so it's going to go 1, 2, 3, 4, 5, 6, 7 from left to right. Then comma. Now you don't have to enter, I'm going to press enter, you don't have to. You could just do it kind of there, but I kind of like to separate things out here. Test, obviously scores. And that'll be, the test scores will be the y data, so going up and down, so 35, 42, da 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 da. And then you'll see on a scatter graph, you get little dots, right, the points of data. There'll be a pointer, hours revised 1, test score of 35, so there'll be a dot there. And then 2 and 42, there'll be a dot there where they intersect, where they cross. You know what? Stop talking about it and just show it, right? Definitely. So we're going to show it with the show method. It's really that simple, right? So we plot the data there onto it, and then we show the data. So let's just save it and let's run it. And there we go. Classic example of positive correlation, strong positive correlation. It looks like this. So it goes from there and it goes up like that. So this line, you could imagine drawing a line, joining the dots, like join the dots. It pretty much is just a diagonal line from bottom left to top right. Classic example of positive correlation, a very strong positive correlation. I deliberately made it so with the numbers, right? So the sorry sausage down there, who studied for 1 hour thinking that's a good idea and didn't do very well on their test, okay. And then also a sorry sausage, I'll be honest, only 2 hours work, well, they still didn't do very well. Meanwhile, up here, right, the person who takes their life seriously, someone who studied lots, 7 hours, they've got the best of the lot, right? They've got the best score, right? They're the one who did the best, right? And you can see as one increases, the other increases. That's positive correlation. But furthermore, we've just used matplotlib to plot out a scatter graph. So each of these dots is a data point, right? So for example there, hours 6, percentage will be about 80. Let's just check it. Can we identify that? We should be able to do 6 and it's 81. Now, I didn't put on here the labels because, you know, when we're doing a graph, we like to put a label for the x-axis, left and right, and we like to put a label for the y, and we probably want to put a title as well to let people know what it's showing. Because at the moment, of course, if you just look at that, if you put that into your presentation, so maybe into your PowerPoint slides, nobody knows what it's showing. What do you mean? 1, 2, 1, 2, what? What is it? So you need the title and all to show that. Or if you put it on your website as well, remember you can export these things, you can save these things as PNGs and whatnot, and then you can put them into websites as well. But let's put on the labels. So we've done this before, like I say, with a bar, but it's the same thing. It's just going to be X label, right? X label method, and in here you put the string for what the X label is. Hours revised, so maybe number of hours revised. Okay, and of course Y label, fairly straightforward. We're going to drill into plot there again into that code from matplotlib, and it's going to be Y label method, and it's going to be test score percentage, right? Percentage of questions correct, and we can give it a title. Well, guess what? It's the title method, and in here we're going to put I don't know, test score percentage for children who revised a number of hours. I know that's a rubbish title, but I'm thinking on my feet here, and that's the best I can do at the moment. The point is, all I'm trying to show you here is you got X label, Y label, title, and then you show it. Remember, you're going to show it at the end. This method shows the data at the end. Make sure you've done all of the fancy stuff here that you want to do, colours and all the rest of it, whatnot, lines of best fit or whatever. You've done that first, and then you show it right at the end. Okay, the steps in your algorithm. Let's save that, and let's just make sure that we are indeed getting all of the labels. And yes, there we go. Number of hours revised. Test score percentage for children who revised a number of hours. Cool. So there we go. That's our technique card on it. You can mess with this, practice with this, see if you can get negative correlation and no correlation. See if you can do that, and have a go at that. In fact, I'll go over it as well now, because that's kind of fun to show you. If you wanted to pause it, stop it, go and do some practice, please do, and then come back and watch it, or you can just watch it now and then have a go. Okay, whatever you did, let's carry on. So this time, let's, instead of hours revised, let's go for something that's going to be a negative correlation. So not hours revised, but hours TV watched. Okay. So somebody watches TV for 1 hour a day, someone else is watching TV for 7 hours a day. Let's have a look at what's going to happen to the test results, right? So let's say this time, the person who the person who watched 1 hour, only 1 hour of TV, they are the person who does the best. They get 95. See how we're kind of reversing it? And then the person who only watches 2 hours is getting 81. And then we go to 72%, and then we go to 62%, and then we get to 53%, not so good, right? 42%. And the child who's watching 7 hours of TV a day, besides going blind, is also not doing very well at all at school, or indeed with anything in life other than sitting on a chair watching boring television. But now you're going to see negative correlation. So that means as this one's increasing, this one's decreasing, right? So as this one's going up, as you're watching more telly, you're getting worse and worse test results. Remember, not necessarily causation, but in this case it probably is, right? It probably is in this case. Hours revised is no longer, you see that error? It's no longer there because it's now hours TV watched. Okay, test scores, that's all the same. Number of hours, let's just change this so it doesn't confuse us. Hours TV watched, and test score is still there. Test score for children who watched number of hours of TV. Number of children who just wasted their lives. Okay, so let's now have a look at that and see the difference here. Yeah, right, there you go. That's negative correlation, classic negative correlation. So you're going sliding down the slippery slope to oblivion down there, right? So you can see as the number of hours TV watched increases, the test score decreases. Okay, so that's negative correlation. Positive correlation was going like that, no correlation, it's like that. You can see it, you could imagine that line sliding down like that. So the next question is, what about no correlation? What about stuff where there's just no link at all, there's just no correlation, there's no pattern here, just kind of almost random, if not random? Well, then you would see dots everywhere. And let's just give you a quick example of that. So let's get something, hours TV watched. Hours pet sleeps, right? So the hours your pet sleeps, is that, you know, is there a link here? The hours your pet sleeps to how well you do in a test? Probably not. Probably going to see no correlation. So let's just throw in some relatively random numbers. I don't know, 28 there, and then 52 there, and then 35 there, and 63 there, maybe 38 there, 73 there, and I don't know, 60 or yeah, 61 there, something like that. So just kind of throwing those down. Of course, it's hours pet sleeps, so we need to change this here for the X. So hours pet sleeps like that, and then of course I'm not going to change all the. In fact, I'll just comment all of these out so they're not going to confuse us. I don't want to waste time just changing all that. The point is, we're just looking at changing the data so we can see no correlation. Let's save it and let's see. And there we go, kind of no correlation. It's kind of just randomly scattered everywhere. You're not getting that nice line, and you're not really getting that. It's just kind of dots everywhere, right? And that's no correlation, just dots everywhere. Okay, so there you go. That's how you can plot out data on a scatter graph using matplotlib, using Python code. Really cool, really useful. I hope you enjoyed the video. I hope it was useful. And as always, until next time, take care.